Hello students of the A-Level AQA Computer Science Paper 1, in particular Section D, in particular 2026. Welcome to this video that I'm calling 10 useful things about Ent Simulator. Or wait, what's it called? Sorry, Ent Simulation, because you're not simulator, you're not kind of like being the end, you're simulating an ant hill and colony. All right, so let's put the timings in. It is 25 seconds in. The first thing, the menu. This is 0025. I'm doing the timings at the same time. Go to my actual original, make that a little bit smaller, and then go to the top. No, the top, not the bottom. Right. Whatever, anything complicated, like those two 12-mark questions at the back of the section D, is likely to need to have a new menu option. So there's going to be like maybe like 4 of the marks or 3 of the marks on the menu option. So it's good to know how the menu options work. There's display menu, so if you need to kind of add something, you just add it in here. We've done that in a number of videos in the series. And then in here, we get choice, and this display menu first, then get choice. And then there's this big if-elif structure. So know where the menu is. That's kind of like a bit easy, but my point is like, don't forget about the menu, because even if it's something that looks complicated, if there's a menu in there and you do it well, which means that you go into whatever new method they've asked you to create, because they might give you the name. The method doesn't need to work, but like just by creating the method with the name, you get a mark. We've seen the marks come in this other video. Then, you know, knowing where the menu is and do it quickly is helpful when it's going to be on the day and you're going to be under time constraint. Next up at timing 013042. Okay, ends grid, I didn't put it in the right place. That's going to be nice. Ends grids, nest pheromones. Those are the arrays in the simulation class that really hold the state of the game. So the grid is a collection of cells, but otherwise we don't have a data structure for the actual grid that we can access by grid. Instead, all of those objects, the nest, the ons, the pheromone, inherit the entities class. But this is where the state of the game effectively exists. So it's good to know that anything we want to change the state of the game beyond the state of a class in terms of the encapsulation, and spoiler alert, it's advanced stage in the simulation class, will need to pass the state of the game by reference, by passing those lists. So it's good to know where they live and where to find any of these things. Next up, this is going to be probably a bigger one at 0235, let's call it. Simulation.AdvanceStage. This is really where the magic happens, because simulations, again, because of this encapsulation, the simulation class is the only class that really has enough information about the game. In particular, if you need to do input validation, likely to be your 5-marker at the beginning of section D, input validation on the, you know, a grid location, then the simulation is the only class in the game that knows the size and where the boundaries are. Hence, this is in number of row, number of columns, but those nest-ons pheromones here are used in advanced stage, because this is where, again, just like the simulation knows everything, the place in which things change in the simulation is when we advance the stage. So it makes sense that it has to be Simulation.AdvanceStage that really controls the state of the game. And it starts by effectively updating pheromones, ons and nest, by updating the strength and maybe deleting some pheromone. Then you get the whole ain in self ons. So for the ons, advanced stage takes care of the interactions between the ons and the rest of the game, the stuff that's outside the ont. So moving the ont is done by the ont class, but here this is where we may drop some food off at the nest. I'll talk about food in one of those 10 items later. Or this is where it picks up food, right? If it's not carrying any food and there's some food on the current cell, then it picks up the food on its back, and that's one click. Otherwise, just move. There's some pheromone stuff if it's carrying food, but this is ChooseCellToMoveTo, and the rest of the movement is taking care of that. And then you've got this, which we need to click advanced stage, because all of those classes, pheromones, nests, ons, have an advanced stage, and their states need to update as well. So the advanced stage of the simulation calls the advanced stage methods on each of the classes in each of the lists where it keeps track of the state. Next up, and it is at timing 0435. Why not? Food, not objects. Yeah, food. The other thing that's really important in the game is the food, and the food is not its own object. Instead, if you look, the food is an attribute of the cell class. So if I do search for class cell, this is where, if there's food on the ground, or good friend def advanced stage, but in the simulation class, right, this is current cells get some food, because that's an attribute of the cell, and it's also an attribute of the aunt, which is like the food that the aunt carries. And the place here, I'm going to show you in WorkerAnt, but like you'll see the kind of current food carried, right? And then the thing at the top here for food carried, and add food to nest. This is where the nest class as well has a food level. So the food is a number that starts as an attribute of the cell. When it gets picked up by a n, this number gets moved to the back of the aunt instance by the update, the advanced stage in the simulation class. And then same deal, the aunt will carry it back to the nest. And then in the same advanced stage that we've just seen a minute ago, we move that number, we zero the number on the aunt and then add that number to the food in the nest. So this is how the food works in there. Next up, the next meat of the thing at timing 5:59 is WorkerAnt, not PorkerAnt, whatever, but like ChooseCellToMoveTo, that's also the other thing that's a little bit fiddly. Certainly we've seen it quite a lot in the zigzag tasks. Again, may not have given an impression of like what is important. Like I know we've not touched anything much to do with pheromones in the zigzag task, for instance, whatever, right? Kind of it's I don't know, I don't even know I'm showing you this, what we're talking about. I've already forgotten. ChooseCellToMoveTo, yes, of course. So it's def choose. ChooseCellToMoveTo is defined at the aunt level. So there's going to be some section C questions, and it's true that last year the skeleton code had no OOP at all, which freaked a lot of people out. And in this one, the amount of OOP is equally freaking a lot of people out. You people are never happy. We have some really good OOP in that you get some OOP that is done that showcases the concepts you will have learned this year. Inheritance, obviously, as well as polymorphism. So the aunt class defines a whole bunch of methods. Advanced stage at the modem just kind of ages the aunt, and ChooseCellToMoveTo. There's two of them at the aunt level, and the WorkerAnt is the one. This is sparse, just to say here, but it's defined the signature, so it's not overloading, it's overriding, and that's and then it's overridden by the child class, the WorkerAnt. That's the one where we move the aunt. And here we have three modes of movement. If the aunt is carrying some food, we kind of do a beeline for the, it's if elif, then if elif, meaning that it might move diagonally, right? It's kind of just going to it's going to go like diagonally, it's going to go towards the nests in like almost a straight line, almost, because it's going to go diagonally and then either vertically or horizontally. But if it's not carrying food, which is the elif over here, it will, so that's the important thing, right? Because this doesn't know anything about the rest of the game. Advanced stage of the simulation class that we were talking about earlier will pass it a list of neighbors, which is actually a list of indices of neighbors inside the underscore grid list of cells. This is how you get back to the cell object. And this is, if there are pheromones around, this is the index of the neighbor. And I think, I can't even remember whether it's the index in this list. No, I think it's the index in the grid list. Because then this, you'll see towards the later, like zigzag task, I remember like messing with indices of like a list of indices, and it's like, it's getting tricky to explain. But yeah, so if we get some pheromone, we're going to choose a random neighbor based on the one with the strongest pheromone. We find just like we go to that one. Otherwise, we are going to do a random neighbor, and this is where we have a helper function. This is private. Well, it's protected, but like this is only present in the WorkerAnt class. Am I lying? No, it's only in the WorkerAnt class, because aunt doesn't necessarily need it. This is how the aunts move. Next useful thing at timing 09, call it 20. By the time I've typed this, yes. The Nest.AdvanceStage, which is advanced stage like this, and probably here. This is, we've touched this a bit less in the zigzag task, so if you've not watched the whole playlist, which I encourage you to do before paper 1 next Wednesday, which is just in a week's time at the time of recording and publishing, I encourage you, so that you're not going to catch it, because I think we've only touched it in like one of the zigzag tasks, but it's important. I don't even know what pheromone advanced stage do, probably do something around the strength. I realize we've not really looked at this much. but the Nest class, because the advanced stage of the simulation will advance the stage of all of the classes in the simulation. The advanced stage, the cat making a catmeo of the Nest class is the one that deals with feeding the ant. So this is, it figures out how much food it needs and subtract it, and then once we're out of food, or like if we kind of like don't start running low of food, we start culling one per turn. If we're running further low on food, we're culling a second one per turn per stage again, and if we've got at 0, we curl a third one per stage. The ants to curl, I'll talk about this in a minute. We keep track of the number of queens in the nest, and then whereas if we have some food, so this is in the if of any of the, this is the most sensitive, right? Like, so if we have some food, then this is also where ants are born. And this in particular contains the, if they ever ask you to do something like you've got a so many percentage chance of this happening, this is the design pattern and where to find it. That was the nest class. So this is where they're born. Here they feed, and indeed this is the only place they currently die. This is an undying. We just pop a random index of the ants list. Importantly, because this affects the state of the game, we pass nest, ants, and pheromones that come from when we call advanced stage. So I'm going to have to go to advanced stage of the simulation class, which, yes, this one, because it takes many number of stages. The advanced stage of the nest is here, and we will, the simulation class needs to pass the state of the game to self, ants, and pheromones, which I think might be the next useful thing. It is! Excellent! So at timing 11:47, okay, the encapsulation and passing list, this takes me quite neatly to where I was if you're watching this. Frankly, I mean, this is going to be what, like 15-minute stops? You might want to watch the whole thing, but it's important to be able to zip past, I'm going very fast here, to a specific timing. So I'm guessing we're going to call this one 12:05 then. Yeah, so as I was just saying, if you've not jumped to 12:05, the way, because the state of the game really lies in those three lists, nest, arguably grid, but the cells don't change much. Like inside the cell objects, we may see some food decrease. That's the only thing that changes in cells. Nests, ants, and pheromones, though, each have, the nest objects, ants objects, pheromone objects, have an advanced stage. So, and some of that advanced stage needs to know also the state of the game. So in that instance, the nest advanced stage needs to know the state of the game. So the simulation passes nests, ants, and pheromones. Because otherwise, the nest class does not know about how many ants are about, or like what the pheromone states of play. I don't really know why the nest needs pheromone, by the way. I'm like a bit sus, but why would it need pheromones? It's not using it. Interesting. This is done with this very ponderous thing when it passes a list and returns a list. So at least you do, but otherwise, like, of course, like this is all passed by reference. So if you change the list, it is mutable, and the actual list in the simulation class, the attribute of the simulation instance, will also get updated. This is how things are encapsulated. You will see this pattern a little bit of everywhere. So in the workaround, this is why we need to doesn't know anything about like where it is. I mean, it knows where it is by row and column. It doesn't know what, like, whether that's the edge of the grid, whereas like right next to the nest, what pheromones are around. And we don't even pass to the end class the list of pheromones like we do the nest. Inexplicably, by the way. I don't know, they would ask, I can't imagine them thinking, to be fair, that would be a good way to test this, but I would mark this as more than and treat this as more than a 12 mark. But it's possible you might need to, I mean, in fair, in here, as no, this is nest. Advanced stage of the workerant is advanced stage of the ant, and all of it does is, well, it passed nest pheromone, nest ant pheromone, but it just updates stages because there's nothing specific to the worker ant to advance the stage. That could be something. I wonder if it's passing, no. Yeah, so it's defined here as well with nest, ants, and pheromones, and never really used anywhere. I might be out of consistency, maybe so that it maps neatly because those things sometimes in other languages, that might take a different shape. I don't know, but that was the encapsulation. Let's not slow down. I said this would be finished in 15 minutes, not the case. But at 14:45, Simulation.GetIndex. Yeah, this is super useful. Because now this is where if you actually need to code, like to know what thing, sometimes you get something that row and columns, because row and columns, if you go, yeah, probably underscore, yeah, that's better. Self underscore row and self underscore column are attributes of the entity class. So anything that is an entity, so an entity pheromone, a cell, a nest, will know where it is in the grid, but there's no other conception of the rest of the grid. Particularly, it doesn't know like the size of the grid. The only thing that has a whole view about where things are is the simulation class. And so the simulation class has this very useful little helper method called GetIndex, because the way it's organized, it's a one-dimensional list ultimately, and because the way it's been populated is just organized like this. At least we don't need to iterate over every them and check their row and column, because this is how we do a lot of other things in the next bit I'm going to show. But here, if you have a row and column, which you can get from GetRow and GetColumn of anything that inherits entity, like aunts and pheromones and nests, then you can know which cell it is in the underscore grid index. So this is GetIndex in underscore grid. You pass it a row and column, and it's just, you kind of multiply it to find an index, and that's going to be where it is in the underscore grid in the thing. This is quite, yeah, this is useful if you need to get from row and columns to the actual grid object. If you need to get for the grid object, the cell object, forgive me, in the grid array to row and columns, or any object to row and column, get row and get column in the entity. I should mention this because that's kind of the reverse, right? Get row slash get column. Now, speaking of entity, I didn't even I must have done this very thought through when I wrote the list, which was just too far back ago, like this morning, for me to remember. But speaking of entity, we have IsInLocation, which we have used an enormous amount of time for good reason. That's InSameLocation. Sorry, I keep forgetting. Yeah, so it's InSame in the membrane. Blast from the past for the appreciator of Cypress Hill. Hello, my name is Dr. Green Thumb. Right, InSameLocation is a method, yes, of the entity class, which will just give you, pass it another entity, meaning anything that inherits the entity superclass, and it will check whether those two things are in the same place. Now, this is just comparing rows and columns, right? Get row, because they all have self row, you don't need to get row, and you know the other thing's an entity, you can do get row. So the row and column thing is done for you here to say, is this in the same place? It's particularly useful. Often you might need to apply this as a filter over iterating the list. So if you have a look at where it is used, it's quite useful too. This is to find the pheromones that are in the current cell when displaying details, either cell details or get area details. Right, the number of pheromones in the cell. You go here. We're trying to go from the cell to the pheromone. We don't need to go via the indices and stuff. We just iterate over the pheromones, and we're like, is it in the same location? Get nest in cell, presumably, get strongest pheromone in cell. This is to display details. This is where it's defined later. Display details defined. No, that's what it's defined. And here, nest in cell. Yeah. In simulation, that was the first time it's used. So if you want to try and figure out something is in a given cell, but you could also have like an aunt is at its own nest. Aunts will contain, will be linked to a nest via the, this is, that should be like number, I guess like, no, I'm not going to put like a 9 prime, but the aunts, if just the class aunt, yeah, just the class, please, right? We link aunts to nest by knowing the coordinates of the nest in the aunt class. This is really in particular so that worker aunts can find their way back to the nest when they're carrying food. And finally, this is very useful if you, well, I think the early zigzag tasks skew towards like making aunts die. The list removal design pattern, which is super useful so that you don't get tripped up at 912. This, I am referring to the fact that in Python in particular, remember this is in other languages, and well, actually in other languages you may have the same problem. When you're iterating over the list, either you're doing for a in, so if I go to remove like pheromones, I can't find it now. Right, here, this is a good example, right? Here we're iterating over the pheromones, and some of these are going to need to get deleted. This is those that have reached strength 0 after we've advanced their stage. They've completely evaporated, vanished, right? Kind of decayed is the word I'm looking for, because that's the word they use here. Now, we can't remove it from a list that we're iterating in. And even if we're using an explicit integer iterator, we have set the bounds of our iteration. So if we start removing something from the list, we're going to iterate one more. It's going to be a whole faff if we need to fix this. So instead, we just make a note of, we want to make a note of the stuff to delete. So start with an empty list and just append to this list whilst we're iterating over the list in which we want to remove elements. And then we're iterating over the list that we want, the elements we want to remove, and remove them. If you are using, since we are using, those will contain the actual elements, so pheromones or ons, if you need to kill ons. This is not how the Nest kills ons. It does it by like a random random location in the list. That's why it uses pop, because it does it by index. Whereas here, we're using remove because we're doing it by object. Again, probably useful to know those list operation Python function. And that is it at a great timing in 2052. That can't be right. This was 2012, wasn't it? Or did I miss? No. It's going to have been 2012, but I've been 18. I'm going to punt 18. I'm going to need to fix it later in the thing. I didn't want to, it's more helpful with the chapters, but it's boring enough for me to record them. But like if I have to watch them again through the chapters, it's annoying. If anyone in the commenter wants to do chapters of the video, I'm sure it's going to be super useful. I'm sure it would be even more useful to us this earlier in the series. Those were the 10 useful things. If you only watch this one video in this series, it should be this one, which again I should really have said at the beginning. But yeah, those were, I hope that any or all of those things will be useful to you in a week's time. And certainly they're not enough to, in their own, like to nail a question, but remember, like all of the marks are distributed from bits of the question, and knowing how to do bits of the question fast gives you more time to tackle what would be more difficult for you in the question. I'm talking like this is more likely to be like towards the 12 markers at the end of section D. So thank you for watching, and keep on practicing and revising and doing some tasks and coding yourself. You can't just be watching the videos, by the way. But thank you for watching them anyway.